Welcome to IoT Real Talk. No fluff, no filler, just real pros talking about real programs, real challenges, and real results. The automotive industry is facing its biggest transformation, the move to software-defined vehicles. Cars are becoming connected, intelligent platforms that can be updated and improved throughout their life cycle. That shift changes everything: how vehicles are designed, how features are activated, how customer experiences are delivered, just to name a few. But getting there takes much more than over-the-air updates or OTAs. Automakers must contend with fragmented systems and legacy platforms. So, what does it really take to turn the SDV from vision into scalable business reality? To answer that question, we've invited SDV expert Prabin Pradhan, Aeris' own head of product from our Automotive Business Unit, to join us on this episode of IoT Real Talk. Hello, everyone. I'm Susanna Song, co-host of IoT Real Talk. John is unfortunately on assignment, so I will be soloing here with my colleague. Hi, Prabin. How are you?
Hello, I'm good. Thank you very much. Thanks for the opportunity to talk here.
Well, great to have you. I know John and I have been wanting you to join us for quite a few months here, so great to be here next to you. Let's start with, what does software-defined vehicle really mean, and why is it such a major transformation for the auto industry?
Uh, that's a very great question. The software-defined vehicle is a very broad topic in the automotive industry. Different companies, different people emphasizes different aspect of the software-defined vehicle. But here in Aeris, what we define software-defined vehicle is a vehicle that is kept fresh through continuous software improvements throughout its life cycle. So the major transformation is that the vehicle becomes a connected digital platform that can evolve throughout its life cycle. So the change, what we're really talking about, the change is from a shift from hardware-led product to software-enabled platform. That is what we're really talking about it. And an example or the analogy that I can give is, before 2007, there used to be a many features phone, and after 2007, iPhone came about, and there was a big transformation that was happening in the smartphone industry, where there was a feature-based phones transformed into a software-defined phone or a software-defined platform. And that the similar concept is being applied in the vehicle also, and that is the software-defined vehicle concept that we have been talking about.
Yeah, that's a great example. You know, for years, a lot of the connected car conversation has focused on OTA updates.
Mhm.
And actually, in episode 6, Raj Kanaya, VP and GM for the Automotive BU, talked about how complex OTA updates can be for connected vehicles.
Mhm.
But but OTA is still just one part of the SDV story. Why
Absolutely.
isn't OTA enough on its own?
Yeah, OTA is a great topic, right? It's the foundation of the software-defined vehicle, but OTA is actually a delivery mechanism. It allows the software to be updated remotely, but it does not make itself a software-defined vehicle. In order to really become a software-defined vehicle, you really have to look at it from the holistic side of it, of the ecosystem, all the way from the vehicle to the backend to the ecosystem. So that applies from the vehicle architecture, the cloud platform, the data pipeline, the observability, the security aspect of it, the release management, the compliance, consent, the service operation. You have to actually consider all this aspect of it. And OTA is a very essential tool, or is a very essential, important delivery mechanism. But what OTA answers is, how do we update? But it does not answer what is the software-defined vehicle. And what software-defined vehicle answers is, how do you continuously design, operate, and improve and monetize the vehicle. So that is the difference between beyond OTA is for us. It's not only doing a OTA update mechanism, but to enable the OEMs to continuously design, operate, and improve the vehicle throughout its life cycle.
From your perspective, working directly with auto OEMs, what's making this transition so difficult?
That's a great question. Again, right? If we really look at the analogy of the smartphone features phone, to the vehicle side of it. With a smartphones, you have typically one CPUs, or you're actually focused on certain specific use cases. But when you are talking to the vehicle, there is many issues, and you are actually looking at the customer interface, customer interactions to actually driving the vehicle. So there is a functional safety aspect of it, the security aspect of it, the consent management, the transportation from one location to another. So it is actually much more complex. And the OEMs also have many legacy platforms also, that it is actually more from the distributed architecture to actually now getting into a software-defined vehicle. So there are many aspects of it. In addition to that, there is a business model issues where the OEMs primarily used to have a business model where you actually build vehicles and sell it, one-time vehicle sales. But now the OEMs actually need to move from not only launch and maintain, but to continuously operate and improve also. So there is a big shift from the technical aspect of it, but not only from the technical aspect of it, but also the cultural and the business and the business model aspect of it. There has to be a big transformation that needs to happen within the automotive industry for the legacy, primarily for the legacy OEMs, to actually really add up and realize the full value of the software-defined vehicle.
Mm-hmm. And I've heard you, Prabin, talk about the requirement for kind of this digital backbone for connected vehicles. Can you elaborate on that for our viewers and listeners today?
Sure. What is a digital backbone, right? A digital backbone is a common platform layer that connects the vehicle, the cloud, the OEM system. There are many systems, the OEM system, partners, ecosystem, the operation teams. There are many of that actually involved in the connected car ecosystem, and the digital platform, the digital backbone is a common layers that connects all of them together. And it provides services like a vehicle identity, the connectivity management, the device management, the OTA orchestration, the data ingestion, configuration management, the digital twins, observability, the security, consent management, API management, lifecycle operations. These are all of these layers that actually this digital backbone actually provides. This is a framework that provides a common platform that is used all the way from the vehicle to the OEMs platforms to the ecosystem partners, everybody. And this is the digital backbone that is going to be used. And in a simple terms, it is a foundation that lets OEMs manage the vehicle as a living digital products. And again, the analogy, if you really look at the analogy, again, I'm going to keep on going back to the smartphone, the iPhone. When you're actually, it's very relatable, and you can actually see it. You can actually visualize, you can see it now, but that's not how it started. It started before 2007. They actually went through the similar kind of transformation, and it is becoming more of hey, this is sort of expected. The similar transformation is happening within the automotive industry also. So, for example, simple applications that we use day-to-day basis is a calendar. When you are updating a calendar, before 2007, you actually might have a Palm Pilot or something like that. You update in your device. It does not get translated into any other things. You cannot look into the browser. You cannot actually change anything. But now you have your calendar. You can actually look it in your computer. You can look it in your phone. You can look into multiple devices. All of those are synchronized. And the applications could be different for different applications, but it is still actually synchronized. And that is the digital backbone that actually they have built into it, so that you can actually synchronize with all the different applications, devices, and it becomes seamless integrations to enhance the user experience. And the similar kind of concept is going to be applied in the vehicle also.
Yeah. What I'm hearing is with this digital backbone in place, definitely OEMs are considering how vehicles are designed and delivered. Um, but then how do you continue to manage that continuously over time? That's a very complex task.
It is a very complex task, right? And this is one of the things I keep on highlighting to OEMs is there are companies like Aeris who actually specialize on actually managing building this kind of digital backbones. And this is sort of a commodity also, but this is sort of a specialized skills also, that the OEM should actually leverage those from Aeris or partners like Aeris but then they can focus on actually differentiating features. So it is a very complex task. It needs to have its own roadmap as the technology keeps on moving forward, and as we are actually the technology is within the vehicle to the cloud. A lot of the concept from the cloud is actually coming to the vehicles also, and how do you actually synchronize the vehicles to the cloud is becoming an essential part of it. And this digital backbone, in Aeris terms, what we call it is a vehicle sync. Is how do you synchronize the vehicles to the backend continuously so that you are actually looking at it as the cloud as an extension to the vehicle architecture. So it becomes a one homogeneous architecture between vehicle to the cloud. And that is the product that we're actually developing, we are enhancing, and the OEMs can actually leverage the product that we have been developing so that any of the services, the ecosystem services, you don't have to worry about any of the interfaces directly to the vehicle. You can actually interface from the backend side of it. Again, there is a shift in the paradigm that I'm talking about. Traditionally, how the features are developed is the vehicle features are uh, feature centric. That means a marketing person will go and say, I want to actually have this feature. And engineer goes and looks at it. Okay, this is the changes I need to make. This is the MQTT message that I need to apply between the vehicle to the cloud. This is the CAN messages that I need to define between the one issues to another. That works up to a certain level. If you are trying to develop if you are really trying to develop features at scale, like how iPhone actually does it, that kind of developing features at scale really is not scalable in this feature-based development. You really need to change the development paradigm from feature-based development to a platform-based development. And in order to actually have this platform-based development where everything is synchronized between vehicle to the cloud at all times, then now you can actually develop the services. It can be applied in the backend, or it can be applied in the vehicle, and it just works. That's the backbone. That's the continuous enhancements that we need to do. And for this one, OTA update is very essential part of it, but OTA update is not sufficient in order to actually have this kind of solutions in the future.
Yeah, when you talk about synchronizing data, it's one thing to synchronize cell phone data, but to be able to scale for all the complexities and the amount of data for a vehicle, and then the geography, the expansion of fleet across the globe. W- Where does the vehicle data fit into this transformation? I mean, there's so much to keep in mind for an OEM to make sure that the right data is being synchronized, and I can't even imagine the
Absolutely.
complexity there.
Absolutely. The vehicle data is a very, again, the key part of it, right? The way we
Mhm.
look at in Aeris is the data is a feedback loop. And that feedback loop is used for OEMs to understand how vehicles are behaving in the real world, improve quality, safety, as well as provide new services by third parties. You also need to actually worry about the regulatory part of it. So with that in mind, the way that we have been actually developing within Aeris, we have a concept called a digital twins, but it's a different version of a digital twins than how the industry is talking about right now. The way that the industry is talking about right now is collecting the data from the vehicle, put it in a digital twin so that you can simulate, you can validate, you can actually test it on the backend side of it. And the way that we're really talking about digital twins within the Aeris Automotive is a two-way synchronization. The concept of actually two-way synchronization is that if the vehicle gets updated in the vehicle, it gets synchronized in the cloud, as well as if the vehicle gets updated, if the data gets updated in the cloud, it gets synchronized in the vehicle. So it is a two-way synchronization that you are actually doing it, and that's the concept that we talk about it. So when the services are being developed, it's usually the CRUD operation, create, read, update, delete operations that the services are being done. And now you don't have to worry about the MQTT message or any of those signals that you need to actually define it. So this is the concept that you can actually apply to develop features at scale. But data is still very important. Going back to the data part of it, the data in the vehicle is very complex, and that is one of the specialization that we do with our digital twins. Is some of the data can be updated only in the vehicle, gets synchronized with the backend. Some of the data can be updated from the backend, it gets synchronized in the vehicle, and all the data does not have to be synchronized all the time. Because, for example, if you look at the wheel speed, the data gets updated every 10 milliseconds, and those might not be, for all the use cases, those might not be updated. And that's one of the differentiating factors that we're actually applying in our digital twins, is to understand how the vehicle data and the backend data needs to be synchronized so that you can lower the cost and apply and synchronize the data that is applicable for both vehicle and the cloud, so that you can develop the features at scale.
What new customer experiences or revenue models then become possible?
So revenue model is a great topic, right? It has been talked for, the data monetization has been talked about for a long period of time. The industry really has not realized that data monetization, because of different reasons. There are only certain aspects of the use cases that the data monetization really works out. For example, insurance companies. But on the other hand, data are very important for certain use cases, and to actually provide new services and features. So it's not only the vehicle data, but being able to access the vehicle is equally important to actually monetize the data. And that's why this digital twin concept is applicable for us, because it is a two-way synchronization. You can actually see the data from the vehicle, but you can also update the data in the vehicle. So you can actually, the third parties can create the services on top of this vehicle sync platform that we're actually developing, so that you can actually monetize the data. The bigger monetization comes not only accessing the vehicle data, but also being able to control the vehicle, or also being able to provide the services. And that's what we are actually focused more on, the on the monetization aspect of it, being able to grant access. But when you're giving access, you certainly have to have access control, role-based access control, and all of those security mechanism in place. But that's how we're looking at the monetization aspect of it.
This is very interesting, Prabin. For OEMs listening who are looking at this transformation, and this is really resonating, curious, what should they build themselves, and your recommendation on where they should look to partners or platforms to be able to
Yeah,
accelerate?
yeah, absolutely right. Many OEMs have a big engineering department. I used to be an engineer, so if you ask, hey, I want to actually solve this problem, I want to build everything. Uh, and that's how I used to be also. But when you're looking at from the product side of it, when you're looking from a high level side of it, it might not actually make sense as a company to build everything. So our recommendations to the OEMs is that OEMs should focus on the brand experience, customer relationship, the vehicle strategy, differentiating features, the safety critical decisions. That's their core. At the end of the day, you are actually developing a vehicle, and OEMs are really good at developing the vehicles aspect of it. The core foundation, the core design of the vehicle side of it, OEMs are excellent in developing that aspect of it. In terms of the backbone, the digital backbones, there are partners, many partners out there, or a platform that is actually capable of actually providing these capabilities. So the OEM should consider the partners or a platform for common digital backbone capabilities, such as the connectivity, the device management, the OTA operations, the observability, again, the compliance, the data pipeline, the scalable cloud operations. All of this can be actually, OEMs can actually focus or leverage the partners, so that the winning model is not necessarily build everything or outsource everything. The winning model would be owning the differentiation while accelerating the commodity foundation, or leveraging the partners. So in other words, build what differentiates by what accelerates. That's the model that we actually recommend to the automotive OEMs.
Well said. Final question here. You know, Raj actually said in episode 6 that OEMs know they need to move faster. I mean, I think that's
Mhm.
universally known. But as automotive leaders who prepare for the SDV future, what would you say in terms of where they should start? Because
Yeah,
there's a lot to do, but
there
where
is a
should they
lot.
start?
Yeah, exactly. So SDV is a reality. Everybody is working on SDV,
Mm.
right? So you are not actually developing vehicle for the past. You are actually developing vehicle for the future. So the SDV, and in certain cases, we also talk about ARDV, but let's focus on the SDV. The OEM should focus on the SDV strategy, but they need to think beyond OTA update. It is not only OTA update, right? Establishing a digital backbone is a key part of it. So aligning software and the vehicle lifecycle process, rethinking the partnership, and identifying the high value use cases is a key part of it for OEMs to actually think forward, right? The priority should be to create a platform that reduces the complexity today while enabling software driven services for the future. Software defined vehicle, like I mentioned, is a very broad topic. There is a lot of capabilities, possibilities in the future, but you cannot get everything at once. So what the OEMs need to think about is, okay, these are the possibilities, but how do I make the system less complex so that I can achieve in the future in a more of an evolutionary approach that I can actually uh, truly realize the software-defined vehicle capabilities in the future. That's how they need to define it, and the recommendation is for them to think beyond the OTA update.
All right. Well, thank you so much, Prabin. Thanks to our listeners for tuning in. If you have feedback about today's podcast or questions for the Aeris team, please contact us at podcast@aeris.net. Until next time, I'm Susanna Saw, and this is IoT Real Talk.
Thank you very much.
From all of us at Aeris, thank you for listening to IoT Real Talk. We hope you'll join us again for more real stories from real practitioners shaping the future of IoT. Tune in on Apple Podcasts, Spotify, or YouTube, or visit aeris.com/IoT podcast.